To understand cloud security, you have to look at what happened to the physical data center. The server racks, the locked doors, and the physical firewalls have been abstracted away into a virtual environment. Cloud computing is the on-demand delivery of IT resources, like compute power, database storage, and applications, accessed over the internet with pay-as-you-go pricing. Because Amazon Web Services owns and maintains the physical hardware, you no longer manage a physical building. The traditional security perimeter provided by a locked door and a private network cable is no longer within your direct control. Because access is instant and global, digital identity functions as your primary security perimeter. Every request to your data begins with an authentication check, making identity management the first and most critical gate in your security stack. AWS manages this environment through the shared responsibility model. It defines the specific security obligations held by the provider versus those held by the customer. Amazon is responsible for the security of the cloud. They physically secure the global infrastructure, protecting the data centers and the underlying network hardware. You're responsible for security in the cloud, managing data, network groups, and most importantly, user identities. The highest level identity is the root account. It holds absolute power. Because it can delete your entire infrastructure, never use it for daily tasks. Reserve it for initial setup. The goal of AWS security is to lock away that root account and systematically build a layered defense. You do this by applying the principle of least privilege, giving users only the specific permissions they need to perform their jobs. We begin with human access. In AWS, every physical person in your organization should be mapped to exactly one unique IAM user. These users typically log in through the AWS Management Console, which relies on a standard username and password. To manage these users efficiently, we use IAM groups. Rather than assigning permissions to individuals, you assign them to a group, like developers or operations, and simply add users to that group. However, passwords are a point of failure. Even with a strong password policy requiring complex characters and frequent rotation, a single compromised credential can expose your entire account. To mitigate this, AWS mandates multi-factor authentication, or MFA. MFA requires two distinct elements, a password plus a device you own. This can be a software-based authenticator app generating a temporary 6-digit code, or, for higher security, a hardware-based MFA device providing a physical key to authorize the login. With MFA enabled, a stolen password is not enough to gain entry. The physical token provides a hard stop that prevents unauthorized access, even if the human layer is compromised. Not all access is human. Applications and automated scripts also need to interact with AWS, but they do so through programmatic access. Because a script cannot type in an MFA code from a smartphone, it requires a different method of authentication. This is where we use access keys. These are used when interacting with AWS through the Command Line Interface, or CLI, and the Software Developer Kit. Access keys come in two parts. The access key ID functions as the username, while the secret access key functions as the password. Because these keys are raw secrets, they must never be shared, emailed, or saved in your code. If these keys are exposed, an attacker can bypass the console login entirely. A safer alternative for service-to-service communication is the IAM Role. Roles allow AWS services to interact with each other using temporary credentials, eliminating the need for permanent, hard-coded keys. Mismanaged access keys represent a severe vulnerability precisely because they are designed to bypass the manual friction of human MFA. Proving who you are is only the first step. Once authenticated, the system must determine your authorization, the specific actions you are allowed to perform. In AWS, authorization is governed by JSON documents called IAM policies. Every policy is a set of explicit rules. The effect block determines an allow or deny. The action block defines permitted API calls, like listing servers or reading databases. The resource block restricts those actions to specific assets. AWS logic is deterministic. If a policy does not explicitly allow an action, the request is automatically denied. The system ignores human intent. It only executes these JSON rules, ensuring that least privilege is enforced at the individual API level. Security is not a one-time configuration. As your team grows and projects change, your IAM architecture naturally decays. To maintain the principle of least privilege, you must move from static configuration to active auditing. For an account-wide view, you can generate an IAM credentials report. This provides a snapshot of every user in your account, showing the age of their passwords and the rotation status of their access keys. For more granular detail, you use IAM Access Advisor. This tool shows you exactly when a user last accessed a specific AWS service. If the data shows a user hasn't accessed a service in 6 months, you can confidently remove that permission, tightening your security without impacting their work. Continuous verification through these auditing tools is the only way to prevent privilege creep and ensure your identity perimeter remains intact. A secure cloud environment is built on unique users, organized into groups, protected by MFA, and restricted by JSON policies that enforce the principle of least privilege. Your security is no longer defined by the physical location of your servers, but by the scope and integrity of your authenticated permissions. As a cloud practitioner, your mandate is to centralize your privilege management, enforce programmatic hygiene, and use auditing tools to verify your security posture relentlessly.